Oh, look at the graph. Aren't they pretty? This one's easy. This one over here is easy. Okay. Alveolar ventilation. Okay, so this is how our respiratory drive, right? In other words, how vigorously are we breathing? Arterial PO2 is on here. Look, it's reversed. Okay, so 0 is over here, 160. So high to low. Okay, and then on this graph is PCO2. And all you really need to know is this top one. Because what we've done in this graph is we've said, okay, if our PCO2 stays at 40, how does our alveolar ventilation change as arterial PO2 changes? Okay, so in other words, if PCO2 is normal and happy, then we can see that as oxygen concentration increases, we breathe less often. Now, if that sounds familiar, it should, because we come back here. Because it's this one, right? It's just flipped around. Okay. So that's this. So PO2, the point of this graph, the lesson here, PO2 doesn't generate much respiratory drive until it gets below 60, right? What did I say? Until PO2 falls below 100. We'll keep these numbers the same, okay? So in other words, if our PCO2 is normal, what I'm trying to get across here is PCO2 is the thing we breathe for, okay? So if we keep PCO2 normal, the oxygen concentration doesn't matter until it gets really low, too low for life, and then we'll breathe to get more oxygen, all right? Now, this one's a little more complicated because it's taking a bunch of different ideas and putting it into one graph. We still have alveolar ventilation, okay? So respiratory drive, respiratory rate and depth. We have alveolar PCO2 along the x-axis. All right, so this is combining PO2, pH, and PCO2 and their effect on alveolar ventilation. Now, I will say I think this is an advanced concept and one outside of ICU medicine you're not going to use very often, okay? So I guess what I'm saying is please do not spend hours and hours trying to fully grasp every bit of this. Okay, I'm going to try to tell you the bits that I want you to know, okay? First off, left shifts. You can see, okay, so the red lines are a pH of 7.4. The green lines are a pH of 7.3. Now, if you compare the numbers, what you can see is that at the lower pH, in other words, when the curve is shifted to the left, we have more ventilation for the same PCO2. Now, the importance of that, this does match what you already know, okay? The body doesn't like a pH of 7.3, right? That is too low. It's intrinsically going to want to breathe faster to raise that pH, right? So the pH all by itself is going to tend to have an increase of alveolar ventilation for a given PCO2. Now, if we add to that oxygen differences, well, if our pH is low and our oxygen is low, well, we're going to have the highest ventilation for a given PCO2 in that case, right? Because we have all of our things. We're breathing for oxygen, we're breathing for pH, and we're breathing for PCO2, right? Whereas out here, like if we look at a pH of 7.4 normal, PO2 of 100, that's normal, okay? Then we can see that still as alveolar PCO2 increases, alveolar ventilation also increases, but it's furthest down the PCO2 line. In other words, when everything else is normal, when PO2 is normal and pH is normal, then we have the highest PCO2 for a given alveolar ventilation. Okay? So what this is saying is all three variables are going to affect the outcome. pH is going to make you breathe faster for a given alveolar PCO2. a low PO2 below 100 is going to make you breathe faster for a given PCO2. And of course, PCO2 is one of the primary drives to respiration in the first place, right? So in all of these graphs, you see they have a positive slope, right? Because as alveolar PCO2 increases, we breathe faster, okay? So a lot of stuff in one graph, but it's the relationships that we built up to here, right? So there's not anything new here. It's just lining them all up. I did add this, I think, today. I was trying to make this a little clearer. Now you see how these lines stop? That's just to keep the graph looking pretty. Okay, these lines would continue to go up, right? Because if your PO2 was 100 and your pH was 7.3, if your PCO2 was 50, well, by golly, you'd be breathing, 50 liters per minute, right? So I think they just stopped the lines so they wouldn't cross over each other and make it harder to read. They wouldn't really stop there. All right.